Before we get into the notes on factor labeling, let's just talk about some of the things we know about calculating with fractions. So let's say that I have the fraction 3/2 and I'm multiplying times 1/3. We know that we're going to multiply the numerators and multiply the denominators. But before we even get started with that, we know that we can simplify some of these fractions, right? So if I take a look at this, I can see that I have a 3 on top here and a 3 on the bottom here. So those can cancel down to 1/1. So when I do 1 times 1, I just end up with 1 on the top. And on the bottom, I end up with 2 times 1, which is 2. So rather than go through the work of multiplying and then simplifying, I can cancel out to start with. Let's talk units and fractions now. So let's say that I have grams over 1, and I'm multiplying times milliliters over grams. The same principle works as with our numbers on the previous example. So before I go ahead and do my multiplication, I can see that I have grams in the numerator on this fraction and grams in the denominator in this fraction. And so those simplify to just 1. So then I multiply across the top of the fraction 1 times milliliters, and I get just milliliters. And on the bottom, I get 1 times 1, which is just 1. And we know anything over 1 is just itself. Now, in factor labeling, we are going to use a lot of conversion factors. And before we get into the actual notes again, what I want to make sure we understand is when we have a conversion factor, like let's say 1 minute equals 60 seconds. We're going to use this conversion factor as a fraction. And when we have it as a fraction, we could, in order to cancel our units, either set it up as 1 minute over 60 seconds, or we can set it up as 60 seconds over 1 minute. And we're going to use this in a way to make all of our units cancel so that we get to our target unit. Now that we have that established, we can go ahead and take some notes on the factor label method. So the factor label method is target 1.9. And if this sounds familiar, it's because it's the same unit as the metric system. And we can use this target in order to help us convert between different units in the metric system or not in the metric system. So what is the factor label method? The factor label method, or sometimes it's called dimensional analysis, but here at Lake Forest we call it the factor label method. It's a technique to convert from one quantity to another quantity. And how we do this is we use conversion factors. And the conversion factors are going to help us provide the link between the unit that we are starting with, that we want to convert, to the new unit that we want. So the new unit of measure. And we use these conversion factors as fractions. And we're going to multiply them together, and we're going to arrange them so that all the units cancel except for the unit we want in our answer. So that's why the little intro is helpful to remember how do fractions cancel each other. Now, conversion factors. You know a lot of conversion factors. You know that 1 foot is 12 inches. You know that 1 minute contains 60 seconds. But you don't know very many that help us convert from the imperial system that we use in the United States, so like inches, feet, and miles, and the metric system. So let's go over some helpful conversion factors. These conversion factors will be given to you on every test or quiz, so you do not need to memorize. But you're going to use them quite often. So something that can help us convert between units of length is that 1 inch is 2.54 centimeters. So you can see this is helping us go from the imperial system to the metric system. But maybe if the length is longer, something that might be helpful is that 1 mile is 1.609 kilometers. That's why when you run a 5K, you're running 3.1 miles. 1 pound is 454 grams. So this can help us when we're converting masses. And then even though this is the imperial system, it's not a conversion that a lot of people have memorized. So I do give it to you that 1 mile is 5,280 feet. So just keep those in mind when we start doing our conversions, that those might help us convert between the imperial system and the metric system. So let's give this factor labeling a chance. Let's look at example 1. So in example 1, we're trying to convert and find out how many minutes are in 22.6 hours. So what I like to do is I like to make a plan. So what conversion factors am I going to need? So if I take a look, the unit that's given to me in this problem is hours. And I'm trying to convert from hours to, in this one, minutes. After I figure out what I have and where I'm trying to go, I can think, do I know a conversion factor that helps me get there? So do I know a conversion from hours to minutes? Yes, I do. And that conversion factor is that 1 hour is 60 minutes. Okay, so let's go ahead and actually set this up. So what unit do I have and what unit am I trying to get to? So let's set this up. I always want to start with what I'm given. And in the problem, I am given 22.6 hours. Now, if it helps you, you can put this over 1 to start with. But what I like to do is I like to just set up my first fraction after that. But if it helps you kind of visualize, you can think that this is over 1. And now I want to set up my fractions so my units cancel. So my conversion factor is that 1 hour is 60 minutes. And because I have hours right here in the problem, I want to put hours on the bottom so that the hours cancel. And what I'm going to have on the top is minutes, because my conversion is that 1 hour is 60 minutes. Now, why I set this up this way, right, is so my hours in my first fraction cancel my hours in the second fraction, and what's not canceled are minutes. And now I'm ready to go ahead and use my calculator. So what I'm going to do is I'm going to multiply the numbers on the top of the fractions. So I'm going to plug into my calculator 22.6 times 60. And when I do that, my calculator tells me 1,356. Now my units on that, because I have canceled my hours, are minutes. But this is chemistry, so we're not quite done. We still have to figure out our significant figures. So our significant figures in the first number, 22.6, that has 3 sig figs in it. Now, do you remember Rule 5 back when we did significant figures and I said, that'll matter later? It's later. So Rule 5 says that any number that comes from a definition or from counting is an infinite number of sig figs. And because 1 hour is exactly 60 minutes, not 61 minutes, not 59 minutes, 1 hour is exactly 60 minutes, this is an infinite number of sig figs. So when I want the least number of sig figs, because I'm multiplying, I'm going to round my answer to 3 significant figures. And 1,356 rounded to 3 sig figs is 1,360. And then don't forget that unit, minutes, and there is my final answer. Okay, Mrs. Gresick, I could have done this before you ever taught me about factor labeling. I already knew to convert from hours to minutes, I just have to multiply by 60. Exactly. But what I wanted to show you is that you already know how to do this. Factor labeling is just showing the steps to convert. So let's try example 2. We're going to need a couple more conversion factors here. So same process. I'm going to start with days. And what I want to do is I want to convert days to eventually seconds. Now, do you know a conversion factor that helps you convert from days to seconds? I don't know how many seconds are in a day to start with, but I do know how many hours are in a day. And I know that 1 day is 24 hours, so that helps me get closer. And then I know an hour to minute conversion. I know that 1 hour is 60 minutes. And then lastly, I can use that to help me convert to seconds. I know that 1 minute is 60 seconds. And so this one is going to be quite a bit longer than the first one because we have multiple conversion factors, but the process is the same. So let's start with what is given. So given to us in the problem was 93.29 days. And I'm going to multiply times my first fraction. So my conversion factor is 1 day is 24 hours. And because I have days right here, I want to put days on the bottom of my first conversion factor, and on top, I'm going to put hours. And my conversion is that 1 day is 24 hours. My next one, I can see in my plan, I'm going to convert from hours to minutes. And because now my hours are on the top, I'm going to put hours on the bottom and minutes on the top. And I know that there are 60 minutes in 1 hour. My next step of the plan will help me convert from minutes to seconds. Because my minutes are on the top and I want those to cancel, I'll put minutes on the bottom and seconds on the top. And I can see that there are 60 seconds and 1 minute. Now I have set all of these up this way so that each unit is canceling as I go. So the days on the top cancel the days on the bottom. The hours on the top cancel the hours on the bottom. My minutes on the top cancel my minutes on the bottom. And my unit at the end is going to be in seconds, which is exactly what the question is asking. So now I'm going to plug this into my calculator. In my calculator, I'm going to multiply all the numbers on the top. 93.29 times 24 times 60 times 60. And because it's all ones on the bottom, I don't have to worry about that. So when I plug that into my calculator, squeeze it in here, I get 8060256 seconds. But not quite done. Significant figures. So when I go back and I think about my sig figs, 93.29 is 4 sig figs. And then everything after that is time. And time is infinite number of sig figs because those are definitions. So I went around my number here to 4 significant figures since that's my least number. So when I go to write it, I'm going to write 8. There's 1, 2, 3, 4, and then everything after that's going to be zeros, and that's seconds. But oh no, when I do that, you can see that that last 0 just became insignificant. So remember, how can I make that last 0 be significant? The easiest way is just to put a line over it, and that line is saying that 0 is significant. Or if you prefer, you can put it into scientific notation, and in scientific notation, I'm going to move the decimal 1, 2, 3, 4, 5, 6 times. So I'm going to keep those 4 significant figures I want and then times 10 to the 6th seconds. Either one of those would be a great answer. All right, we have done 2 examples with time now. Let's try some examples that don't involve time. So in example 3, what we're trying to do is we're trying to convert from miles to millimeters. So up first, I can write miles over here, and I eventually want to get to millimeters. Now millimeters are in the metric system. If you remember, M is for milli and M is for meters. So I'm going to use that abbreviation there. So now, unlike the last one where you probably know all of the time conversions, here you might be thinking, I don't know something that can help me. But what we want to do is we eventually want to get from the imperial system to the metric system. So take a look at those conversion factors on the last page of our notes that have something that gets us from distance in the imperial system to distance in the metric system. And the first thing that sticks out to me is the miles to kilometers version. And why that sticks out to me is because I already had miles. So I'm going to use that conversion. And that conversion is 1 mile equals 1.609 kilometers. And now that I'm in the metric system, I can convert to any other unit of length in the metric system. And there's someone who can help me. That someone is King Henry. So remember from our metric system notes, we know that King Henry doesn't usually drink chocolate milk. And as I take a look at this, I'm trying to go from kilo to milli, so all the way across the metric system. And when I do this, I can look that the kilometers are larger, so it's going to be 1 kilometer is 10 to the something millimeters. And how I figure out how far away it is I see how many jumps it is. 1, 2, 3, 4, 5, 6. So it's going to be 1 kilometer is 10 to the 6th millimeters. And that's the conversions. So now I'm ready to go ahead and set up my fractions. So I always want to start with what I'm given. So I'm given 2.00 miles. And when I set up the fractions, I'm going to convert from miles to kilometers according to my plan. And I want my miles to cancel out. So I'm going to put my miles on the bottom. And I'm going to convert to kilometers on the top. And my conversion factor is that 1 mile is 1.609 kilometers. So now I've converted from miles to kilometers, and I can use my next conversion factor to convert from kilometers to millimeters. Because my kilometers are on top, I'm going to put the kilometers on the bottom and convert to millimeters. And thanks to King Henry, I know that 1 kilometer is 10 to the 6th millimeters. And again, why I've set them up this way, so my miles cancel, my kilometers cancel, and I'm left with the unit I'm trying to get to, which is millimeters. So now in my calculator, I'm going to plug in 2 times 1.609 times 10 to the 6th. And when I do that, my calculator tells me 3,218,000 millimeters. Let's talk sig figs. So 2.00, because of the decimal, those trailing zeros are significant, so that would be 3 sig figs. Now this conversion that I gave you, that's a rounded number. There are not exactly 1.609 kilometers in a mile, so that's going to be 4 sig figs because of the 1.609. Now the metric system, it's like time. 1 kilometer is exactly 10 to the 6th millimeter. That's the definition of it. So that's an infinite number. So when I look, I want to round to 3 sig figs. So when I round to 3 sig figs, I'll do 3,200,000. The 8 makes the 1 round up. So it is 3,220,000 millimeters as my final sig fig answer. Example 4, let's convert 150 pounds to kilograms. Okay, so I'm trying to convert from pounds, and I'm trying to get to kilograms. Again, in the metric system, kilo is K, grams are G, so I'm going to abbreviate it kg. Okay, so let's take a look, because again, I'm going from the imperial system to the metric system. Let's figure out some conversions that can help me. If I look back at my helpful conversion factors, I can see that I'm given the conversion from pounds to grams. And that conversion is 1 pound equals 454 grams. And then, because now I'm in the metric system, and I'm trying to get to something else in the metric system, I can use King Henry to help me. So King Henry doesn't usually drink chocolate milk. And I'm trying to go kilograms, there's the K. And then remember, grams are our base unit. So I'm trying to get to my base unit here. There's no prefix, so I know that's the base unit. So again, a kilogram is larger. So 1 kilogram is going to be 10 to the something grams. And when I count my jumps, 1, 2, 3, it's 10 to the third. And then because I really don't care for scientific notation in my calculator, I'm going to remember that 10 to the third is just 1,000 grams, and I'm going to write that instead of 10 to the third. And that is my plan. That's how I'm going to get from pounds to kilograms by going through grams. So let's set up my fractions. So I'm going to start with 150 pounds. And because my pounds are on top, I'm going to write pounds on the bottom. And I'm going to convert to grams. And I know from my conversion factor that there are 454 grams in 1 pound. Next, I'm going to convert from grams to kilograms. And because my grams are on top and I want them to cancel, I'm going to write my grams on the bottom and kilograms on top. And using King Henry, I learned that 1 kilogram is 1,000 grams. So if you take a look, my pounds cancel, my grams cancel, and I'm left with kilograms, which is what the question was asking. And now for the first time, we have a number on the bottom of the fraction. So what I like to do in my calculator is I like to hit 150 times 454, and then I like to hit equals before I divide by the 1,000. And why I'm dividing is because the 1,000 is on the bottom of the fractions. So again, I'm going to hit 150 times 454 equals, and then divided by 1,000. And when I do that, my calculator tells me 68.1 kilograms. Let's talk sig figs. When I go back, the number 150, there's no decimal place, so that's just 2 significant figures. That conversion factor that I gave you, that's a rounded number. There are not exactly 454 grams in a pound, so that one counts as 3. The last conversion factor, though, that's within metric, so metric to metric, that's an infinite number of sig figs. So I went around 68.1 kilograms to 2 significant figures since that's my lowest number, and that would then just be 68 kilograms as my final answer. All right, last but not least, let's convert 55 miles per hour to meters per second. So this one is our trickiest. That's why we left it to the end, because we're going to be doing 2 conversions in one. What we want to do is we want to convert miles to meters, right? Those are 2 units of length. There's also a time conversion that needs to happen. I need to convert hours to seconds. So I'm going to need to come up with 2 plans. So let's focus on the miles to meters first. So I want to convert miles eventually to meters. So that is the imperial to the metric system. So again, it's helpful to go look back at your conversion factors. And when you do, you'll see that you're given a conversion from miles to kilometers. And that conversion is 1 mile equals 1.609 kilometers. And now you have kilometers to meters. That's within the metric system. We can use King Henry. King Henry doesn't usually drink chocolate milk. And kilo is right here. And meters, remember, are our base unit, not the M. That would be millimeters. And we just want to convert to meters. So kilometers are larger. So 1 kilometer equals 1, 2, 3, 10 to the third, otherwise known as 1,000 meters. So now I have come up with a plan to help me convert my miles to meters. But I still need to worry about how am I going to convert my time from hours to seconds. So let's come up with our plan here. So hours to seconds. This is much easier because I know I can convert hours to minutes using 1 hour is 60 minutes. And I can convert my minutes to seconds, knowing that 1 minute is 60 seconds. So now let's set up our fractions. So what we have here is we have 55 miles per hour. So for the first time, we're not going to have 55 miles over 1. We're going to put 55 miles over 1 hour. So anytime you see this per, what that means is we're going to have a unit over another unit. So 55 miles per hour is 55 miles over 1 hour. So let's convert our miles first. So my plan, right, was to go from miles to kilometers. So because my miles are on the top, I'm going to put miles on the bottom and convert to kilometers. And that conversion is that 1.609 kilometers is 1 mile. So I've done this first step. Now I'm going to convert from kilometers to meters. And because my kilometers are on the top, I'm going to put kilometers on the bottom and meters on top. And so I have 1,000 meters are 1 kilometer. So I have successfully canceled my miles, canceled my kilometers, and right now I have meters. That's great. That's exactly what I wanted. But right now my units are meters per hour still, and it wanted me to convert meters per second. So I still need to do my time conversion. So to do my time conversion, I'm going to use this set of conversion factors over here. So I'm going to set up another fraction. Now, this time, hours, look, they're on the bottom. So in order to cancel, I want to put hours on the top. And my step is to go from hours to minutes. So I'm going to put my minutes on the bottom. And I know 1 hour is 60 minutes. So I now need to convert from minutes to seconds. So I'll set up one last fraction here. And I'm trying to cancel my minutes. So minutes were on the bottom. I'll put them on the top. And then I'm going to convert to seconds. So I'll put those on the bottom. And I know that 1 minute is 60 seconds. So now take a look at these units. I have canceled my hours on the bottom with hours on the top, minutes on the bottom with minutes on the top, and my unit right here is seconds. So if you look at my 2 circled non-canceled units, I have meters and seconds, which is exactly what I wanted. Now, to plug this into my calculator, I'm going to do 55 times 1.609 times 1,000. At that point, I like to hit equals, and then divided by 60 equals, and divided by 60 equals. You could also multiply everything across the top, multiply everything across the bottom, come up with a fraction and divide that way, but I just like the equals. Now, if you plug it into your calculator correctly, go ahead and give it a try. If you plug it in correctly, you're going to get 24.58 in your calculator. And my unit is meters per second. If you didn't get that, you didn't plug it into your calculator correctly, ask for some help. Whew, we still got to talk sig figs. If I take a look, this 55 is 2 significant figures. 1.609 kilometers is 4 significant figures. Then we're to a metric conversion, so that's infinite. We're to time, that's infinite. Time, that's infinite. So my lowest number is 2. So I went around 24.58 to 2 significant figures. That would be 25, and then my units meters per second. And that is factor labeling.